Hi guys, we're back to talk more about, you guessed it, geology, and we're going to talk about the techniques that are used in kind of relative aging technology or relative aging geology. And I want to talk about a technique that's related to this concept of sedimentary facies, as it's pronounced. So a facies or sedimentary facies is basically a distinct sedimentary layer, and it's distinct relative to kind of adjacent layers. And what makes it distinct is that different sedimentary layers are formed in different kinds of depositional or sedimentary environments. So when we talked about sedimentary rocks before, we said, for instance, things like limestone form in kind of marine environments because they form from seashells, and seashells don't form in non-marine environments. But more than just things like limestone, there's other kind of unique depositional environments that lead to the formation of different other kinds of sedimentary rocks. So shale, we can also have shale facies. Shale facies tend to form also in coastal marine environments in that kind of a slightly offshore environment where there's no longer waves crashing. Waves continue to kind of stir up sediment and prevent it from settling out. But when we get a little bit offshore into deeper water, and then sediments can settle down on the bottom, they form a mud layer that eventually can turn into shale. And then there's also distinct sandstone facies, which tend to be also along coastal environments, but they tend to form in the nearshore environment where there's lots of wave action. So anytime you've been to the beach, you see that there's an accumulation of a bunch of sandy material there. And that sandy material is the kind of thing that will eventually or could eventually become a sandstone facies. So we have these distinct layers of rock that sit nearby one another, and they are sitting nearby one another even though they formed at the same time, or even though they may have formed at the same time, because there were slightly different depositional environments in slightly different areas across the landscape. And then there's this important geologic principle that's called Walther's principle, and it tells us that layers that form in horizontal bands, so originally they form in these horizontal bands like we can see in these pictures, but what's interesting is they end up over time getting stacked in vertical columns as the environment changes. So for instance, if we have a change in sea level so that the shoreline is moving offshore, then areas which previously maybe used to have shale in them might then start to have sandstone stacked on top because the shore or the shoreline is moving out over the area where that used to have more fine-grained material. Or in a period of sea level rise, we might see that there's areas of old sandstone that then become covered in areas of shale. And then if sea level rise progresses even more, eventually we might have layers of sandstone that get stacked on top of the sandstone and shale over time as the sea level is moving up onto the landscape. So even though these layers form in these distinct like adjacent facies, they can over time become stacked vertically, and the way that they're stacked tells us a lot about how the environment was changing. So in particular, we have two terms, transgressive and regressive facies, that refer to particular kind of types of events. So transgressive facies refer to the example that I already gave, where we have sea level that's encroaching onto land. And so this might be happening for a variety of different reasons. So we might have melting glaciers like we have today that are adding more water to the ocean. We might have a period of sea floor spreading in the ocean that's kind of basically pushing the ocean water upwards. Or we might have land that is actually sinking down, and so relatively the sea level is getting a little bit higher. So any of these three things could be going on, or multiple of these three things could be going on together, and that could cause the position of the sea level, which in this picture A maybe used to be here, and at that time we had some sandstone forming here, and then shale a little bit offshore, and maybe limestone in a more offshore reef environment. But as the sea level is progressing up the landscape, what we'll start to see is that the shale starts to slope inwards, just as the limestone does, just as the sandstone does. And then if that process continues even more, then we can see that we start to have vertical stacks of layers. So if we drill down in this particular point here, we might see limestone stacked on shale, stacked on sandstone, which is kind of a telltale sign of, oh, this was occurring during a period of sea level rise. So maybe that indicates something about climate, or again, seafloor spreading, etc. Okay, so the depositional environment shift inland, and then the finer grain material, which tends to be the shale is finer than sandstone, and limestone is often even finer than either one of those. The finer material ends up, and more marine material ends up being stacked on the coarser grained and more terrestrial material. And then the opposite can also happen when we have a period of sea level fall, and we refer to these kind of distinct patterns of the sedimentary layers as regressive facies. So this might be happening when the world is getting colder and more water is being pulled into ice caps and glaciers. We might have a period of seafloor spreading where the ocean floor is actually sinking and accommodating more space for water. Or we might have what's called isostatic rebound, and that's when basically the mass or the weight of the continents is changing in such a way that it's getting a little bit lighter and it's kind of buoying back up. And so the landscape is rising, and then the sea level is falling relative to the landscape. So again, all three of those things could be happening, or some of those things could be happening, but in any case, we would be seeing a shift in the position of sea level. And so when this happens during this regressive kind of facies forming period, we would have these depositional environments that are shifting out to sea, and that causes the shale to start to encroach over the limestone, and then the sandstone to start to encroach over the shale. So we would see, if we drill down into a column, exactly the opposite. The sandstone stacked on top of shale, stacked on top of limestone. And in that case, we have the coarsest, more terrestrial material stacked on top of the finer, more marine material. So these are really great clues that we can see in the sedimentary record that can help us, one, learn a little bit about like the timing of the way these things were happening, but also gives us a lot of information about what was going on in these particular periods. So we can see these kinds of things in the Grand Canyon. The Grand Canyon is, of course, nowhere near the ocean today, but at the time that these layers were forming, there was a big inland sea in that particular area. And the sea wasn't constant, it was rising, it was falling, and it was leading to these different patterns of kind of transgressive and regressive facies that are currently stacked in the area where we have the Grand Canyon today. Okay, that's a good stopping point.